As part of normal treasury operations. And essentially, attackers compromised the safe wallet UI and targeted the Bybit's routine operations to then drain the cold wallet funds. Just a few stats about this hack. The attack happened last year between the 4th and 21st of February. Approximately $1.5 billion have been lost. 401k ETH dispersed across intermediary addresses were stolen. And the threat actor is a North Korean linked group that is called Lazarus Group. They have been quite successful in leveraging Web3 projects for their own benefit. Just a few numbers here to see the impact of this hack. So the Bybit exploit alone was profited more than half from the total crypto-wise in 2024 and almost half for 2025. That's a very, very impactful hack. And I think these numbers give you this perspective as well. Regarding the hack anatomy, how attackers exactly proceeded to compromise Bybit. So first, the hackers compromised the safe wallet developer laptop, and they did this via social engineering. With this initial foothold, they were able to get access to the AWS token session, and with this, they gained permission to do operations on their own infrastructure. The S3 bucket that they found was used to work as a CDN to deliver the front-end assets of SafeUI to the users. And essentially, from the window of when the attack happened, everyone that was visiting SafeUI wallet was also downloading the malicious JavaScript that they that they uploaded in the S3 bucket to be delivered for their front end. However, the code was lying dormant there. It was waiting for the right time so that when Bybit's transaction routine operation was going through, they knew exactly the target address that they were using. And the JavaScript triggered and deceived the users by changing the UI to not show what was exactly being signed as malicious, but something else that appeared normal. One thing that I would like to highlight here is that we mainly see Web2 related mechanism for attacks. Of course, they leveraged their attack to then manage the smart contract proxies and so on. But with the right permissions, they didn't do anything that broke the logic, right? They used it legitimately. So most of the vectors we see here is Web2 related. Now let's take a step back. When we build a Web3 project, usually these kind of projects, they are quite complex. They are working in the scope of distributed systems. Blockchain has a bunch of concepts that are not very easy to understand, and they take some work and some practice to get acquainted to those concepts. So, but when we get engineers to engineer this software and make it run on the Web3, the attack surface of that specific project is only on where it runs, which is the blockchain. Plus, complex projects serve nothing if they don't have any users to use it, right? Because it's basically complex stuff, and we have to make it easy for improved usability so that the users can use this project, our project. So we come up with a bunch of tools, to name a few: SDKs, wallets, dApps, third-party dependencies are already here, just to name a few. And all of them work together to improve the usability of our Web3 projects. Now, one thing worth mentioning is because all these components are connected now, attackers attackers can just target the low-hanging fruits. They can manage to just target the weakest link of this whole environment and the whole component dependency graph here. Now, reframing this diagram to the Bybit hack, we got the Web2 scope, the Web3 scope. On the Web2, we have our SafeUI wallet. And the Web3, we got their smart contract running on the blockchain. And as we saw earlier, it's connected because we need this connection for usability purposes, as I mentioned earlier. Now, we got the attacker there from Lazarus Group. And as we saw also earlier, they injected the JavaScript into the S3 bucket. But that was not the actual exploit, right? That was just part of a whole chain of attack. What they exactly leveraged was this bridge here. And what is this bridge? This bridge is a semantic gap. It's basically how data is presented and interpreted by end users on the Web2 scope, and how data is represented at the byte level for blockchain transactions on the Web3 scope. So the blockchain executed exactly what was signed. The problem was that users signed something they couldn't reliably understand. Now, 1 month ago, there was another attack that shows that attackers and threat actors, they keep leveraging this semantic gap that exists between the two scopes. Where this attack was an address poisoning attack, and as a fun exercise, just for a bit of background, address poisoning attack means we are trying to compute an address whose 3 first characters and last 3 characters of the address are the same as the victim's wallet destination wallet that they want to transfer funds to. And the probability to get this right is bigger than to win the lottery. Plus, the profit is probably the same or much higher, as we saw. So, of course, attackers will continue to leverage this semantic gap and keep attacking our projects because they have huge gains, huge motive, huge incentive, right? Now, I wanted to reference a few other entities of our industry that highlight exactly this problem. Certic, on their Hack 2025 report, they say that supply chain was the most costly attack vector, representing almost half of the total amount stolen in 2025. Plus, phishing compromises followed, being the attack vector with the highest number of incidents, slightly above code vulnerabilities, which is where we have our smart contracts usually being categorized when they get also incidents. And lastly, Open Zeppelin, in a blog, they said, when we talk about Web3 security, smart contract vulnerabilities tend to dominate the whole conversation. However, unlike smart contracts, which operate within the EVM constraint, as we saw earlier, a single exploit in the blockchain whole infrastructure can cripple the entire network, leading to downtime and loss of funds. Now, what can we do about it? What are some of the small steps we can take that gain us and that we can leverage for the highest defensive capability, right? Let's go through a few. On the protocol domain, do not neglect human factor when developing your Web3 project. Hedera is a good example of this. Despite supporting EVM address equivalence, natively it tries to shrink the semantic gap that we saw earlier by having the following. We have a consistent uniform entity ID format. For instance, accounts, they have this specific format of shard number, realm number, and account number. And it's all base 10. It's way easier to understand, way more human-friendly than base 16. We also have self-describing transaction IDs. So a transaction is composed of the payer account with the format we saw earlier at a valid start timestamp. And finally, HIP15 introduced an optional 5-letter checksum. So like when users want to transfer their funds, they can input a checksum which helps them validate that they introduced the right number of the account. It gives them power, in a way, to keep being safe when managing their wallet. On the supply chain domain, we got a few as well. Dependency colons, I think, it's one of the biggest wins. What it means is that there's a delay between dependency updates and its adoption on your project. So let's say you have a 48-hour dependency colon. It means that all the dependencies that are updated within that threshold, your project is not going to update to those versions. It will wait. It will wait 48 hours. And this gives us room to, if any incident, any alert happens, it will basically make us have time to respond. Another one is log files for your projects and for the dependencies of the dependencies of the dependencies, right? Because what these do is they record the exact dependency version instead of having ranges there. So every time you build your project, you have the exact dependencies that you want it to build upon. And it's not just important this for your project, but the projects you depend on and you fetch from the registries, they also need to have a log file. Or otherwise, when you build them, they will also compromise your project because of the dependency graph. Version pinning is another example to lock the software. On this example, I have the GitHub Actions, where on the first scenario, we have v35. And this is flexible, right? If the minor versions change, you will automatically fetch the latest version. And on the other scenario, we got a chasm of the exact version we want to use. And finally, scope packages, which is more on the NPM native NPM registry native scope. And these restrict dependencies in a way that, OK, let's say you have a project, and you set the package name to just a string. And usually, in our companies, we have multiple projects, multiple internal projects. Your project might be the dependency when you build it on the future of another project. And if you set a name that is not scoped, that has not a namespace, then any attacker can register this name. And whenever you build your project, it will fetch the registry first. So it will inject your project with malicious code and not your dependency. So as a good practice, always scoping your package names, it's good, even if it's not a dependency, because in the future it might be. And these controls don't stop change, right? They just make change intentional and observable. On the phishing domain, so one thing that I like to say and to highlight is that hackers, they are not some very special species in a way. They are just like us. They are builders, they are engineers, they have the same background. The difference is the questions they ask and how they focus their energy. When you're building something, we are asking, how can we build this to make sure the requirements are there, our user use cases are according and mirroring exactly what we implement. But as a hacker, you are asking, how can I break this? Is there a workaround? And because these people, they ask different questions, they get different results. But usually, we're kind of the same. So adopting a hacker's mindset can help you as well when you're building your project. Be skeptical. If something is too good to be true, it probably is. We've seen this when we have people reaching out to candidates, and they send a take-home challenge, but it's not legit. It's malware. Trust, but always verify. And in the end, you are the last line of defense of your whole project. Because even if you have the most hardened Web3 system running, in the end, attackers can always try to bribe your employees, try to leverage your interests and make you execute malicious code that you didn't intend to. And that can compromise your project, as we saw with Bybit. Another one is ownership attitude. This alone is so easy to scale because it helps and has an extended coverage, because users turn from passive executors to active defenders. reduces the phishing success, promotes verification and accountability. And finally, a proactive mindset. This encourages early questioning, validation, and you have time to strategize. You are not running and being reactive and just trying to fix the holes, right? You have time to think. Ultimately, every contributor is a security enabler and becomes part of the security chain. On the Teams domain, really? Okay. So it's over. Okay, so pretty quick. We don't have time to go through this, but if there's one thing that I want you to go, one message to take home from this session is to be a bit more like Neo from the Matrix. Just load some security skills. Now with AI is very easy, and you can leverage yourself to also account for security on your own project. Pretty quick, there's some Hedera bounty tracks that you can go on our booth with some prizes. Please check that as well. And we also have an Hedera CTF, $3K still on the prize. And finally, thank you all so much. Thanks Ashcraft, and thanks my team for helping and supporting on this session. Thank you so much.